In this video, we'll see how PDB Reader handles glycolipids and also how you can model a heterogen that is not in the CHARMM topology files. The structure 4HG6 is a protein and complex with lipids and a carbohydrate polymer, specifically cellulose. Type in 4HG6 on the first page of PDB Reader, then click Next. On the Step 1 page, select all heterogens for modeling, then click Next. Note that UDP is uridine diphosphate. If we select CSML search, we are told there is no appropriate residue in the CHARMM topology files. Instead, we can use the CGenFF or CHARMM general force field to generate the appropriate topology and parameters. This is already selected, so let's move on to the next heterogen. The residue named LDA in the PDB entry is lauryl dimethylamine oxide, a type of lipid. If we search CSML, then we'll see that this residue is defined in the CHARMM topology file for lipid detergents and is named LDAO. Select it, then click Apply. There are several other features worth mentioning on this page. First, the terminal group patching section allows you to modify the N and C termini of a protein chain. In this case, N-ter and C-ter use the standard residues. ACE or ACP causes the N-terminus to be acetylated, and none omits the terminal group. On the C-terminal side, we're given options for CT1, 2, and 3, which add a methyl, amine, and methylamine group, respectively. Press the question mark for a complete list of abbreviations. The next feature we'll see allows us to add or remove disulfide bonds from the structure. To remove a linkage, click the minus button. To add a linkage, click Add Bonds. A list of cysteine residues in each protein chain is generated. For example, in the protein segment B, cysteine residue 163 and 430 are available for forming a disulfide bond. Finally, the cellulose chain can be modified by pressing the Edit button. A new window will pop up with the full sequence and graph of the oligosaccharide. An individual sugar can be changed by selecting a new sugar from the drop-down list, and the sequence graph will be updated in real time. For example, we could change the leftmost sugar to fucose. To add another sugar to the end, press the last plus button. To add a branch, press the plus button of the sugar where you want to branch. To change the carbon atom where the glycosidic bond is occurring, select the number from the left drop-down box. Similarly, you can change between alpha and beta linkage. In this case, there's no such thing as a 1 to 4 fucose link, so we'll instead use 1 to 3. Finally, the root of the graph can be changed to link the sugars to one of several predefined lipids, or to one of the protein residues. When you're satisfied with the glycan, press Update Sequence. The new sequence will be updated here. When you're ready, press Next to generate the modified structure. If everything went alright, you'll see the normal summary page. We can see the result of our sugar modification by clicking View Structure. One of the differences between fucose and glucose that can be seen pretty easily is the 6th carbon atom. Glucose has an oxygen attached to this atom, but fucose does not. So on this side of the oligosaccharide chain, we see a bunch of sugars with an oxygen attached to the 6th carbon. Now let's look at the other end. The last sugar in the chain is here, and its 6th carbon is here. There's no oxygen attached to it, so we're looking at the fucose. Also notice that the missing carbon atoms in LDAO have been filled in. Compare this to this other version with a shorter carbon chain. That's it for this protein. The next protein we'll look at in this video is 1L6X. The previous protein had a sugar chain that was near the protein but wasn't actually a part of it. 1L6X, however, has a sugar chain that is chemically linked to the protein. This particular type of link is called an N-glycan because its sugar is attached to an asparagine residue. Let's type 1L6X on the first page of PDB Reader, then click Next. On the Step 1 page, we see the sugar here, labeled CAR-A for carbohydrate A. This sugar chain branches in 2 locations, which are shown in the sequence with square brackets. On the Step 2 page, we see that 3 disulfide bonds were detected. The sugar sequence is also available for editing. Just like before, if we click Edit, we'll see the sequence. Here are the 2 branches that were mentioned before. When you're ready, close the sugar editing window, then click Next. Your final result should look like this. Here's the glycan, which branches here and here. That's it for this video. In the next video, we'll cover functional oligomers and spin labeling.